This video will work through problem 5.3 from Gapenski's Healthcare Finance, 6th edition. Okay, so in 5.3, we are presented with some data about this organization, a group radiology practice, and they have fixed costs of $500,000. They have variable cost per procedure of 25, and they have and they charge $100 per procedure that they do. So the first thing we want to do, all right, so the first question is construct the group's base case projected P&L statement. Okay, so as we do that, in order to do that, we need to know first what their revenues are going to be. And so their revenues, and our base case is going to be based on 7,500 procedures. So our base case is going to take revenues. So the revenue function, total revenue, is going to be 100 times the number of procedures P, right? Total variable cost is going to be 25 times the number of procedures. And fixed cost is, of course, fixed. So revenue is going to be 100 times 7,500 procedures, which is going to give us 750,000. Total variable cost is going to be 25 times the number of procedures, so 25 times 7,500, right, which gives us 187,500. That gives us total contribution margin, so 750,000 minus 187,000 gives us 562,500. Okay, then we take our fixed cost, which is given as 500,000. Subtract that, and we get profit. 562 minus, or we could put parentheses here, 562 minus 500 gives us 62,500. And so that is the P&L for the base case. So what is, part B says, what is the group's contribution margin and what is its break-even point? Okay, so total contribution margin is given when you have a particular unknown volume. So in this case, the base case, we're assuming 7,500 procedures. So you can then calculate a total contribution margin. Well, what is the total contribution margin? Well, it is the amount of money or revenue that is generated that can be applied against covering the fixed costs towards profit. So it's contribution margin is not profit, right? It is just basically the variable revenues and the variable expenses combined together and applied, and then that can be applied against fixed cost. So once contribution margin exceeds fixed cost, then it becomes profit. So that doesn't really answer the question about what is contribution margin, though, not total contribution margin. Well, contribution margin, you want to know at the individual unit level. So we're looking at how much does revenue contribute for how much revenue do we get for each additional visit, and how much cost do we incur for each additional visit. So to calculate contribution margin, it's going to be revenues, right, per procedure in this case, minus variable cost per procedure in this case. So in this case, revenue per procedure is 100 and variable cost is 25. So we have a contribution margin of 75 per procedure. Now, and if you were to multiply this through 75 times 7,500, you'd get the 562,500. So then the next question is, what is the break-even point or break-even volume? Okay. So to calculate the break-even volume, we need to create the profit function. So we take our total revenue function, which we already said was 100p, right? We take and then we need to create our total cost function, or cost structure. So total cost is equal to fixed costs plus variable costs. So in this case, that is 500,000 plus variable cost of 25p, right? So total cost is 500,000 plus 25p. Total revenue is 100p. So profit, which I abbreviate as with the pi symbol, is 100p total revenue, right? Minus total cost, which in this case is 500,000 plus 25p. Now I'm subtracting total cost, right? So I have to distribute the negative. Okay. And then I'm going to consolidate like terms. So 25p and 100p can be 75p minus 500,000. Okay. So that is our profit function for this particular problem. So if we were to plug in 7,500 visits for P, we'd wind up with the answer we had a minute ago, which is 62,500. Okay. But that's not the break even. In that case, we have $62,000 in profit. Break even occurs when profit is equal to zero, right? Because remember, profit is total revenue minus total cost. So break even is where profit is zero because total revenue is equal to total cost, right? So we have some amount of revenue coming in, and as a result of the number of procedures we're doing, we have some amount of total cost coming in as a result of the number of procedures we're doing. The total revenue and total cost are equal, so we wind up with a profit of zero. So we then set, to find out what the break-even volume is, we set profit equal to zero, and then we solve for the volume. So profit equal to zero, how many procedures do we have to do to get profit equal to zero? So I'm going to add 500,000 to both sides so I can isolate my variable. Then I'm going to divide through by 75, and I get P is equal to 500,000 over 75, which is 6,667. Okay, so that is part B. So if you were to take 6,667, plug it into the profit function, 75 times 667 would equal 500,000. Minus 500,000 gives you zero profit. So that is the volume at which we break even. So now part C says what volume is required to provide a pre-tax profit of 100,000 or 200,000. Okay, so that's relatively simple. Since we already have the profit function, right, which is profit equals 75p minus 500,000, instead of setting profit equal to zero now, if we want to know how much volume we have to do to get $100,000 in profit, all we do is set profit equal to 100,000, right? And then plug that into our profit function. So 100,000 equals 75p minus 500,000. Right? Add 500 to both sides, we get 600,000 equals 75p. Divide both sides by 75, and we get a volume of 8,000 procedures. So P equals 8,000. For a volume of 200,000, for a profit of 200,000, same problem. We set profit equal to 200 instead of 100, right? Add 500 to both sides. And we've got 700 equals 75p, divide by 75, and you get P is equal to 9,333 procedures. Okay, so Not rocket science here, pretty simple. Now it asks us to draw the CVP graph, cost volume profit graph. Okay, so we're going to have cost and revenue on the y-axis and number of procedures on the x-axis. And so I always start, when I explain this, I always start my drawing with fixed costs. So I say, okay, I'm going to draw fixed costs here. Fixed costs come in as a horizontal line. And why are they a horizontal line? Because they don't change with the number of procedures. They're 500,000, whether you do one procedure or 1,000 procedures or 10,000 procedures, it's 500,000 as long as you're within the relevant range. Then on top of the fixed costs, that's where my variable cost comes in to create my total cost curve. So if I do 0 procedures, I have to pay the fixed costs, but no variable costs. But if I do 1,000 procedures, right, with a $25 per procedure variable cost, I'm going to pay the 500,000 plus 1,000 times 25, which is 25,000. So I'd have 525,000. If I did 10,000 procedures, I'd have 10,000 times 25, which would be 250,000. So I'd have a total of, 750,000. So my total cost is my fixed cost plus my variable cost. So this gap between fixed cost and total cost is made up by the variable cost, right? So in my example, at 10,000 procedures, right, I have 500,000 in fixed costs, and then 10,000 times 25, or 250,000 in variable costs, for a total fixed cost of 750,000. Okay, so there we go. We got that. Now we have to draw in our revenue line, and our revenue line is going to start at 0, because if we do 0, we get 0 revenue, and go up with a slope of 100. Oh, and total cost line has a slope of 25, because variable cost is $25 per unit. We get $100 per unit for total cost. The break-even point happens where the total revenue line crosses the total cost line. And we already calculated that to be, I got to grab my note here, 6,667. Okay. So to the left of the break-even point is loss. This is our zone of loss, right? So to the left of the break-even volume is loss, and to the right of break-even volume is profit. So when we're doing more than 6,667 visits, we are making a profit, because our contribution margin exceeds our fixed cost. But when we are doing less than 666,000, we are losing money. Okay, so now we're going to move into part E, which assumes that the clinic has contracted with an HMO that proposes a 20% discount from charges. So what we have to do now is, the key assumption here is that the clinic is going to face a 20% discount to charges across the board for all visits, not just not additional visits. So then the problem asks us to redo parts A, B, C, and D. So here we go. Going back to our original calculations, so for part A and building the P&L statement, we're going to now take a 20% discount on charges. So charges were 100, so a 20% discount point would be 80% of the new charge would be 80% of the old charges, so that means $80. Okay, so the only change that we have actually is the change in charges. Our variable costs and our fixed costs stay the same. So our new total revenue function is no longer 100, but 80p. Okay, so let me move over here. So what is the new P&L going to look like? Well, we start with revenue, and instead of 100 times 7,500, it's going to be 80 times 7,500, and 80 times 7,500 is 600,000. Total variable cost doesn't change. It's still 25 times 7,500, which gives us our original 187,500. Our total contribution margin is now 600,000 minus 187, so that's 500, 3, 1, 413, 412. Sorry, I can't do math. 412, 500. And then our fixed costs don't change, so that's 500. So then our profit now, and this is negative and negative, so 412,500 minus 500,000 is now a loss of 87,500. Okay. So the key thing to remember is your revenues are separate from your costs. If your revenues go down, it doesn't mean that your costs are also going down. So in this case, you probably wouldn't want to take that contract. Now, redoing part B, what is the group's contribution margin? Well, we found the total contribution margin was 412, but as we discussed earlier, the contribution margin is the revenue per procedure minus the variable cost per procedure. So the revenue per procedure was 100, and the variable cost per procedure was 25, but now the revenue per procedure is 80, so the contribution margin per procedure is 80 minus 25, which is 55. So previously it was 75, it's now gone down, right, so it was 75, it's now gone down to 55. All right, and then what is the break-even point? Okay, so with the break-even point, we need to go back and look at recalculate our profit function. So remember, previously, we said our profit function is profit is equal to total revenue minus total cost. Previously, total revenue was 100p. Now it is 80p, but the total cost is still the same. So minus 500,000 plus 25p, right? So the new profit margin is 80p minus 500,000 plus 25p. If we distribute the negative, it's 80p minus 500,000, minus 25p. Consolidating terms, 25p plus 80p gives us our 55p minus 500. So profit is equal to 55p minus 500. And remember, if we want to get to the break-even point, that's the point where total revenue equals total cost. So when total revenue equals total cost, profit is going to be equal to 0. So we set profit equal to 0, 55p minus 500,000. We add 500p to both 500,000, to both sides, and we get 55p equals 500,000, and p then is equal to 9,091 visits or procedures. So significantly higher than before when we calculated that it was 6,667. All right, so that is break even. What if we want to figure out 100,000 or 200,000 in profit? So again, all we do is for the 100,000 or whatever level of profit we want to arrive at, it's simply 100,000 equals 55p minus 500,000. Add 500,000 to both sides, we get 55p equals 600,000. So then P, dividing both sides by 55, P is equal to 10,909. And then finally, if we want to make profit 200,000, then it's 200,000 equals 55p minus 500,000. Add 500,000 to both sides, and you get 55p equals 700,000. Divide both sides by 55, and you get P is equal to 10,909 procedures. Okay, so whenever you're presented with a question about a degree, a level of profitability, it's simply setting profit equal to whatever level of profit you want to achieve, and then solving for it. So break even, you're setting profit equal to 0. If I give you, or if your professor gives you some arbitrary dollar amount for profit, you just plug that in for profit and then solve just like you did for break even. It's pretty straightforward. All right, and then last part is to construct the CVP analysis. So drawing in our original, so that's our fixed cost, our total cost, and the total cost has a slope of 25 because that slope represents the variable cost added onto the fixed cost, right? And so it always has a slope of 20 of whatever the variable, the total cost line has a slope of whatever the variable cost is, right? So in this case, it's 25. None of this changes as a result of negotiating the new reimbursement rate with the HMO. So the original total revenue line, I'll draw it with dotted line. So TR, we'll call it total revenue 1, had a slope of 100 because we were being reimbursed $100 per visit. So for every additional, or procedure, so for every additional procedure we did, we got an additional 100. So we moved up our line 100. Now we're going to be taking $80 per visit. So since 80, so our new total revenue line will have a slope of 80. And since 80 is smaller than 100, that new total revenue line is going to be flatter than it was before. So TR2, where revenue per visit or per procedure is 80, whereas here revenue per procedure was 100, right? So now the slope is 80 as opposed to 100. So notice what changes is the break even, the original break even was here, break even volume was here. Now the break even is moving to the right. We're going to have to do more procedures in order to break even. In fact, what we calculated a minute ago was that to break even at the new cost, at the new revenue per procedure, we'd have to do 9,091 visits, whereas at 100 per, we were able to do 6,667. So we're going from 6,667 to 9,091. And it sounds like somebody's doing some leaf blowing outside my window, and I apologize for the background noise. Okay, so that's the change to the CVP analysis.